Yeah, the rest of the labs for 10 and 11 are really short. So, all right. So, welcome to week 11. What we're doing, actually, this is week 12, but we're doing week 11. Yeah. All right. So, the topic of the day is transactions. So, transactions are actually a really important topic in database um, because without them, the banking world basically wouldn't function. So a transaction is an action or series of actions that carried out by a single user or a program, whatever, that updates the contents of a database. Insert statements, updates, deletes. The difference between just doing an insert and doing a transaction is a transaction is considered a logical unit of work. So each transaction does something to the database, and no part of it alone achieves anything of use or interest. That means it's a multi-step process, but it's treated as one unit of work. When I use a real world example for everybody, I like using getting out of bed. When you're getting out of bed, there's more than one step. It's like you're not like snoring and suddenly you're vertical, right? There's a bunch of steps. And the thing is, if any of those steps fail, you didn't get out of bed, right? The alarm went off, you turned it off, cool. You uncovered, cool. You tried to sit up and you fell back down. Well, you're going back to sleep now. Transaction failed. It's only so a transaction is only considered successful if all of its parts work. So a transaction is considered a unit of recovery, consistency, of integrity. There is an acronym because there's acronyms in everything in computer. Um, it's called ACID. So a transaction has four properties. It's atomic. Sometimes you'll see it written as atomicity. I just go with atomic because my brain has a really hard time saying that word for some unknown reason. It's consistent or it's consistency, isolation, and durable. All right, so something that is atomic. Transactions are atomic. They conceptually they do not have parts. There might be multiple parts to it, but as a concept, there are no parts. It's one whole thing. It can't be executed partially. Every piece of it has to finish and succeed. Otherwise, it's considered failed. It's all or nothing. That's why it's atomic because you can't break it up because, well, when you split an atom, things go boom. If you split a transaction, things go boom to the database. Um, Consistent. The transaction will take the database from one consistent state to another. During the transaction, the database might not be consistent. And I've got examples in a minute to explain that. Isolation. The effects of a transaction are not visible to other transactions until it's completed. So every set of transaction runs in its own little bubble, in its own bubble universe. And when it finishes, the bubble pops, then everybody else can see what was inside that bubble. Um, from outside of the transaction, either the transaction has happened or it has not. It's happening. Either it is or it isn't. The is means the transaction finished and was committed. It isn't means it started and might be running. Who knows? But either it's it exists or not. So this is actually a consequence of being atomic because the entire thing behaves as a single task. If when I click on my button, that's one action. Either it happens or it does not. The fact that I actually had to move my thumb, think about pressing the button, those are all the steps for that. But as far as you guys are concerned, like I got my finger, you can't see me clicking it, but stuff is changing, right? Because you can't see the fact of what I'm doing. Either it is or it is not. Durable. Once a transaction is complete, the changes are permanent. Even if the server were to crash, the transaction must survive that. And there's things in place to make sure it happens. Yeah, so you start a transaction, it becomes isolated, it does all the steps, it commits it, then it's durable and everybody else can see the changes. So for example, we want to transfer $50 from account A to account B. That's something that most of us have experienced. You got your main account, then you got your backup account where you have your money for your hot dogs, because that's your backup money and you're running low, so you got to transfer funds from one account to the other. Now, this is something all the banks do. Now, the order they do it in might be slightly different, but the beginning and the end result's the same. So the transaction would be as follows. You want to transfer $50 from A to B. So A is A minus 50. You write A to the database. You read B. You add 50 to B, and then you write B to the database. That is the whole transaction, which means any of these steps fail, the transaction has to fail. Because otherwise, the consistency. So for atomic, you cannot take money from A without giving it to B. Boom, done. Consistency. Money is not gained or lost. So you start the transaction. Account A has $100, account B has $0. By the end, there's $50 in each. We still have $100 total, but now it's split up over a couple of spots, but we never gained or lost money in the process. Like when you pay with your debit card, you go to the grocery store and you tap your phone, whatever, and you're paid $50 for your groceries. What happens is it takes $50 from you and gives it to someone else. Now, that happens over a series of transactions because obviously different banking systems, but your account has an entry that says amount gone down by $50, and there's an entry that matches that. And it's done as part of a transaction, because if it fails to say you took $50 away, suddenly Loblaws gets $50, you kept your $50, $50 was just invented. Yes, money's a made-up thing, but we don't need to make it up as we go. Isolation. The other queries shouldn't see what's happening to A and B until it's done. So for example, we start the transaction, we take $50 away from A. Anything else running in the database should not see that A lost $50 yet until we put it in B. So it has to be isolated. The whole thing has to happen, but everybody, as far as everybody else is concerned, nothing is happening. Durability. Once it's written to B and it's committed, it doesn't go back. It just doesn't magically go back to A. So A lost $50, B gained $50. That's it. Suddenly, if the server were to restart, A suddenly doesn't go back to 100 and B be at 0 or whatever. All right, so the transaction manager, locks or timestamps are used to ensure consistency. Different database servers do it slightly differently. There's a log. Remember last week when I talked about the log, the binary log? When there's transactions, it has a transaction log where it keeps tracks of the transactions between something called a checkpoint. And I'll be talking about those in a bit. The transaction manager enforces ACID. It schedules the operations. Commit and rollback are the commands used to ensure things are atomic. And I'll be doing all this during a demo, so it sounds a little weird, but trust me, it'll happen. So rollback means the transaction failed. And that means that what it'll do is it'll roll everything back to when you first started the transaction. There's a command called begin, or in some other database server, it's called start transaction. So you go start transaction or begin. After that, everything's part of the transaction. If anything fails, you can issue a rollback and it goes right to the beginning. It's the closest thing to an undo you have in database. While everything that you did while you were doing that transaction, if you roll back, it all goes away. It's like it never even happened. It just throws it away. So picture the transaction as in you've been given a piece of paper to do some work and you write it, and then when you're done, you give it back to the original person, they put it in a binder. But if you suddenly realize you made a mistake, you just crumple it and throw it out. So the first one never saw it because it never made it to the binder. So that's a rollback. Commit means everything worked. You gave it to the person, they snapped it into the binder. It's permanent now. It cannot be lost, or should not be lost. That's, things happen. Also, the moment something is committed, the other clients and transactions can now see the changes you just did. So rollback means undo whatever you were doing. Commit means we're all good. Everybody gets to now see the changes. Okay, so recovery. This goes hand in hand with that discussion about backups last week. So prevention is better than the cure. As always, having a reliable OS, making sure there's security, make sure there's UPSs and surge protectors in place, use RAID arrays to make sure you don't lose a disk, that kind of stuff. You can't protect against everything because life happens. You could have your server sitting in a nice server room and everything's happily protected. And then there's a leak upstairs and it just pours into the server room. It could, but usually when a computer just stops working, the disks are usually still good. You can recover the data. If the water comes pouring from the top, usually it doesn't come back. So system crashes, power failures, disk crashes, like the old style hard drives, the heads would crash sometimes. Like literally, we would hit the disk and scratch the disk. User mistakes, sabotage, natural disaster, bad plumbing, take your pick. I mean, I like using bad plumbing because at my private sector job, the old office space they had until a few years ago, our server room was, we didn't know this, but our server room was under the upstairs bathroom for the floor above us. One day, somebody noticed water coming out from the server room door. And they're like, why is there water? So we run in. Thankfully, it was over an empty rack. We just emptied the rack. There was water dripping from the ceiling. We took down the ceiling tile, and you could see the P-trap for the toilet upstairs. The toilet had clogged and overflowed, and it was dripping into our server room. Good times. So that's why I say, plumbing, because I've seen it. A restore just restores to a previous state. A rollback restores to a previous state of transaction. A recovery recovers the entire database server, not just the transaction. Because in theory, you could have 3 or 4 transactions running at the same time and only one of them fails. Therefore, that one gets rolled back, but the other ones get committed. If you're doing a recovery of the database, everything goes away. Less good. So the transaction log records the details of all transactions, any changes made to the database, how to undo these changes, how we completed, and when. The log is stored on disk. It's never in memory. So if the server just hangs, blue screen of death, kernel panic, whatever, the log is safe because it's on the disk. There's a write-ahead log. The entry in the log must be made before the commit processing can be completed. So the transaction log keeps track of all the steps you did. When you say commit, it takes that and moves it to the write-ahead log. Once it's in there, then the commit finishes. So it takes the steps you did on a piece of paper, copies it into the binder permanently, and then closes the binder. So it sounds like a lot, but you'll see, like honestly, 99% of people that work with databases don't worry about this slide. Like you just know whether the transaction works or it does not. Like the mechanicals of it. Like I know for a while U of O actually had a course dedicated to transactions where they went into the code and the math of how the transaction works inside of a database server. Like they literally had an elective just for that. Way ahead, way above our pay grade in this room. Essentially, you just need to know that there's steps. It takes the log for the transaction, writes that to the disk. When the transaction is successful and is marked as committed, it takes those, adds it to the write ahead log. In MySQL, it's known as the bin log, the binary log, and then it's committed, and then the write-ahead log gets applied to the database whenever it's supposed to happen. Everything. So the transaction log keeps track of things that are in a transaction. The write-ahead log is the actual actions. So the transaction log keeps tracks of all the steps you've done. The write-ahead log only keeps tracks of the ones that were successful. So everything goes into the transaction log. When it's successful, it gets copied to the write-ahead log, and then from there, it's processed. It's so that if the server were to just crash, turn off, whatever, it can replay the log to get back to where it was. As part of a database server restarting, it looks at the transaction log and it looks at the write-ahead log and goes, okay, these transactions are successful. They're not in the write-ahead log. It puts them in the write-ahead log. Or, oh, this was successful here, but the write-ahead log doesn't show that it was ever committed to the database. It will play back everything and then make the database server available. Oh, there's ways to actually get at it to look at it, but it's not something people usually do. It's a very rare case. I've seen a database getting corrupted when I was at Health Canada, and they decided it was just better to restore from a backup than try to fix it from the logs. But sometimes it's just need to know it's there. Well, if it's at the point where you can't even fix it from the logs, then it's recovery. If it's going to take like 3 weeks, but we have people waiting for it, and we're only going to lose an hour of data, sometimes it's better just take the hit. But it's situational. There's not this is better, that's better. It's this is better when, however, this is better if, it's conditional and different places have different rules. So just have to go with it. So system failures. At various times, the database server takes a checkpoint. What a checkpoint is it reads whatever all the committed transactions are that are now been put in the write-ahead log. It'll take those and actually apply them to the database files, like the actual data. A record is made on disk of the ones that are currently running, so transactions that are incomplete, but still running. So there's a checkpoint every so many seconds, like every second or two, it looks at all the changes, applies them to the database. So a system failure means all running transactions are affected. Software failure, power failure, as long as the physical disks are not damaged. If physical disks are damaged, you're toast. Okay, so I'm going to be using a graph that looks like this for the next bit. You'll see basically a green line traveling across it. This is just the initial state of this. So system recovery, any transaction that was running at the time of failure needs to be undone and restarted. Any transactions that are committed since the last checkpoint need to be redone. So transaction type T1 don't need to be recovered because you'll see right here. So the timeline goes this way and basically it just moves this way and T1 self-contained. It'll make more sense actually. Let me go. I'll go through the slides and it'll make more sense when you start seeing the line go through. So when you talk about the transaction log, there's two modes, undo and redo. Undo is any transactions that were there since the last checkpoint. Redo is always empty after the checkpoint. So for each entry in the log, starting at the last checkpoint, if a begin transaction entry is found, it adds it to the undo. If it's a commit is found, it takes a transaction, moves it to redo. All right, here we go. So we started here and time advanced, we hit the checkpoint. Okay, so checkpoint is when the database server actually writes the data to the disk, like to the actual tables of the data. T1 started and ended before the checkpoint, so it's good. We don't even need to worry about it anymore because it's been taken care of. However, at this state, transaction 1 started, transaction 3 started, transaction 2 started. Okay. So 1 started, 3 started, 2 started. The line's advancing. 1's committed. Checkpoint fires off. That means transaction 1 is completely safe. It's been written to disk. At this point in time, 2 and 3 are sitting in the undo pile because they've started, but they're not safe yet. Okay? So then the line continues moving. We start transaction 4. So 4 goes into the undo pile because it's not committed yet. So literally the commit message has not happened. Therefore, as far as the database is concerned, these transactions are not valid. Therefore, they're undo. We're not going to do these. We're just going to take them away. So in the log, you've got 2 entries, undo and redo. Anything that is undo means that it has not completed. So if the server were to crash, it's in process, it's incomplete. Once it's completed, it will go to redo. I'm going to be, as the line moves, you'll see stuff move around. Okay. But essentially, once anything that would be in redo, once the checkpoint fires off, redo is emptied because it's now safe. Like transaction 1 is not in redo because it finished and got checkpointed. So right now we hit the checkpoint, 2 and 3 on undo. We start at transaction 4. Transaction 4 moves to undo because it's in process. Transaction 5 begins. It also goes to undo. Transaction 2 completes. It gets moved from undo to redo. It's kind of like that. It's like one of those concepts that's very computer specific. It's hard to come up with a real world example of this. But essentially, transaction 2 is committed. It goes into the redo pile. It's in the redo pile because it hasn't seen a checkpoint yet. All right, so it continues. Transaction 4 finishes, so it goes from undo to redo. Server shits the bed. At this point, the server just turned off. Somebody walked by and tripped on the power cord. Server just went for a nap. 3 and 5 are in undo. 2 and 4 are in redo. Okay, so everybody goes running to the server room to go figure out what happened. They go, oh, it got unplugged. E1's done. It's been checkpointed. Exactly. So now everybody runs to the server room to go see what happened to the server. Oh, it got unplugged. Fantastic. Time to check who was in the server room. Right? Plug it in. Turn it on. Database server comes back up. It reboots. Database server initializes. It goes, let's check the transaction log. It goes, transaction. So because it in the log, it has the instructions for 3 and 5, but they were never finished. So it takes them out of the transaction log, but it sees that 2 and 4 are completed, so it'll do 2, then it'll do 4 while ignoring 3 and 5. So it basically works from both ends. It undoes stuff and redoes the stuff until it meets the middle and clears the log. Yeah, but they're in redo because they finished after the checkpoint. So what's happened here is there's not another checkpoint before the failure. This is the resiliency thing, right? The durability. In other words, even if the server dies after the checkpoint, these successfully finished. Therefore, they have to be redone. But the server didn't have a chance to actually commit them to the disk. Therefore, it goes, hey, I know how to do these, and they finished successfully, so we will do them. They're in the log saying, I finished this job, but we didn't manage. So, for example, we'll go back to the piece of paper in the binder. I filled out my form, and I put it at the end of the desk. Somebody else filled out their form, they put it at the end of the desk. Meanwhile, two other people are over there filling out their forms. Suddenly, fire alarm goes off. We all have to evacuate. We come back. You could grab those two copies off the end of the desk and put them in your binder. Those ones that were not finished, they'd have to redo it for whatever reason. The paper caught on fire, whatever. Right? So that's what the redo is that pile of paper ready to be put in the binder. The undo is the stuff that didn't finish before the fire alarm, and because for whatever reason you can't trust the students or whoever it was to actually finish it properly, they have to start over. Yeah, that's why it's redo. Okay, so I just really finished explaining this. So I'm going to skip this slide because it's literally what I just finished explaining. Media failures, they're more serious because the data stored on the disk is damaged. Transaction log itself might be damaged. Though that's when you asked, is it better to do a recovery? If the transaction log is toast or the disks are damaged, you're doing a restore. Now, if you're doing the binary log and the transaction log is not damaged, in theory, you can do a restore and then run the transaction log and bring it back up. Pretty iffy. Things are at that point, things are pretty grim for everybody involved. Backups. We talked about backups last week, so I'm just going to skip on that one. Again, recovering from media failure. We talked about doing restores last week. You restore the database from the latest backup, then you use a transaction log to redo. That's the binary log in MySQL. If the transaction log is damaged, you can't do step 2. So usually the transaction log is stored on a separate disk. So if you lose the main disk, you haven't lost the transactions. The risk of losing it all is reduced. There's amongst other things, yes. All right, so the last big item for transaction is concurrency. And this is where all that, I was talking about that course that you had at U of O with all the math. It was all about this. So concurrency means that it's a very large database and there's thousands and thousands of people using it. Like one of the databases at IRCC at any given time has 40,000 people pushing stuff in and out of it. Like they're not all doing like click, 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 but they're filling out a form, hit save, but they're logged into the system. Somebody else is looking at a different form. So there's, everybody's working. So people are applying for student visas, people are applying for refugee status, that kind of stuff. So many transactions need to be run on the database. Obviously, we want them to run in parallel because it's good, but we still need to preserve isolation from each other. If we don't allow for concurrency, everything is run in sequence. So imagine, okay, there's 5 of us in the room, and we're all going to transfer money from our accounts. And we all start doing it at the same time, but I went first. I do my transfer, it takes half a second. Then you do yours, there's another half a second. But you have to wait half a second. Now she's waiting a full second to do hers, then it's a half second, so he's waiting a second and a half. By the time he's done, she's waiting 2 seconds if you're doing it in sequence. Can you imagine, a bank where you're trying to transfer money and you have to wait behind 10,000 people? You could be waiting 3 days to transfer your money. So we don't want to, that's why we have something called concurrency. You can read entire books on it. Just know that they run in concurrently. So when we run transactions in concurrently, we interleave. So transaction 1 does something, transaction 2 does something, transaction 3 does something, which is where the log comes in because it's keeping track of all the steps for each of the transactions. And that way the undo goes back and erases the ones that failed so that it can then redo the ones that succeeded, right? So it's basically going through the document and taking out the things, redacting all the time, in what order, all of it. And it basically goes through it. Each transaction gets a share of the computing time at the same time. Well, one after another, really, really fast. like for example, I transfer $50, you transfer 50. So I take the minus 50, you do your minus 50, I get my plus 50, then you do your plus 50. But they're all happening one after another, but really, really fast. And it's keeping track of all those steps so that suddenly I do my 50, you start your 50, mine succeeds, then the server crashes. What it'll do is it'll go backwards and look for any that don't have a commit, and just so it's suddenly being me 50, you 50, me 50, you 50, it'd be me 50, you 50, me 50, fail. So in the end, it would be just me 50, me 50, because you failed, it's taken out. Um, so whenever there's issues, sometimes you have lost updates, uncommitted updates, incorrect analysis, because isolation gets broken. There's a lot of smart people that have written really good code to make sure there's isolation does not get broken. Because you know what happens when isolation gets broken in the real world, people catch bad things. Database server, when isolation gets broken, bad things happen to the. Um, so in MySQL, transaction control commands, start transaction or begin. Begin's pretty universal. Commit, roll back. There's one called save point. I'm not going to talk about it. If you really want to learn about it, go look it up. But it allows you to actually do partial transactions. I've never used them once in my career. But you got a bunch of save point ones also. Actually, I guess I have slides for save points. I thought I took those out. All right, so a save point is a marker. So in theory, you have a really long, complicated transaction with like 25 steps. Maybe the last couple of steps are optional. So what you can do is you can set a save point. You go start the transaction, you update an account, you create a save point. Then you do another one and you realize something went wrong. You can actually roll back to the save point and then commit. So you would save this and discard that. You have some control. It's not something commonly used, but it's an option. And different database servers do it differently. So actually, which is why I think I was planning to take these slides out, because it's so different in each server that it's kind of pointless. Um, so yeah. So like, why would you want save points? Every transaction, maybe you only want to roll back. Maybe part of it always has to happen, but maybe part of it's optional, so you can just roll back the failure. Conditional logics. Apply the updates if only certain conditions are met. So you can actually say, oh, I just did this, but now it's not looking right. So let's just undo that and we're going to keep the other work we did. Nested operations, sometimes you need to nest transactions, and that's really dangerous actually. Batch processing, maybe you have a huge batch, like tens of thousands of things you need to update, and you can do parts of it. So for example, you update account A, you update account B, you go to update account C, it fails, so you roll back that checkpoint, then you update D, E, roll back E, F, G, and commit. So you can choose to undo parts of it. But then you have to keep track of what failed, and that's, not so great. Um, Save points are only valid for that one transaction. They only live for that length. Save points are lost the second something's rolled back. And if you're in auto commit mode, it's not supported. MySQL is auto commit mode. When you type in insert into customers and you run it, it's committed immediately. It's called auto commit. Oracle's the other way around. Oracle is in explicit commit mode where you can type in insert into customers and run it. Until you type in commit, it never happened. So different servers behave differently. All right. So a typical point is you start it, perform operation, you give it a save point, you perform some more operations. If needed, you roll back to the save point, then you commit or do a full rollback at the end. It just allows you to undo things if you need to. I've never actually used it. No. So you start, you do some things. You create a save point. You do some more things. You say, oh, darn, that didn't work. So I roll back to the save point. So basically what it does is it exists, and then you can commit it. So this is always saved, but this is optional. It gives you some extra branching logic in the transaction. Like I said, it's not a common thing because usually a transaction is a transaction is a transaction, and you want to keep the whole thing. So yeah. Okay, now I'm going to do my demo and check the time. Oh, we're doing great. Fantastic. Okay. So for the lab, I'm using MySQL Workbench. You can do this with data grip. You could do Workbench for one window and command prompt for another. I'm just doing it all in Workbench to make life easier. All right, I've got a really simple database, one table, a few columns, account ID, account name, and balance. I've even got only 2 rows in it. That's how simple this demo is going to be. Connection 2, same data. Now, this is going to demonstrate the whole isolation thing. So I'm going to in a transaction, and I'm going to go equal to, okay. I'm going to begin my transaction. I'm going to run these two. Okay. And it's account ID. There you go. I failed it right off the bat. Let's try that again. All right. So you can see down here, it says one row matched, one changed. We set the balance to 900. I'm going to go to my other window. See, it's still 1100 because it's in the transaction, but it's not committed. So the isolation part, anybody else doesn't see that this transaction is actually happening. So now I can come here and go commit, and I'm just going to run the commit like this. Okay, commit happened. Now I'm going to come here and run it again. Now it's 900 because it's finished. Everybody else is allowed to see the changes. So now if I were to go back to my first window and I go set balance to 1200. Yeah, you can. You can run anywhere you can type in SQL, you can do this. In actual fact, with CLI, it's actually a little more reliable than this. So I go begin. I'm going to update the account. You can see right now that it's still sitting at 900, even though I just changed it to 1200. But this time I'm going to do a rollback. In actual fact, to prove to you that these things are isolated, I go select star from accounts. I'm going to run this one here. See, it's 1200 here, 900 here, because it's not committed. So in this connection, the transaction's still active, and it's consistent unto itself, but it's not everywhere else. So now instead of doing a commit, I'm going to do a rollback. And I'm going to select star from the accounts again, just to show you. Okay, so there's my rollback. Select star, I hit run. This one went back to 900. This one is also at 900. The banking world operates on this so that bad things don't happen to people's money. It's actually the banking industry that really pushed for transactions. Makes sense, right? Okay, now, nope. Once you commit, it's permanent. You've now reached the do not pass go stage of existence. Okay, so now I'm going to do is I'm going to change the balance back to 1100 like this. But what I'm going to do is over here, I am going to attempt to set the balance to 1500. Okay, I'm going to hit run. Notice what's happening. It says it's running. It's running, but nothing is happening until, and this is going to happen really fast. I go commit here and I go run. Suddenly this one completed. Now, this is where things get tricky with the transactions. So this one started. Okay, before I say that, what do you think the balance is in the account? 1100 or 1500? It's 1500. Because I started a transaction. I started making a change to that record. The other one started making a change to that record, but it was waiting its turn. First one commits, so it becomes 1100. Immediately, the second one starts and finishes. So it became 1100, then it became 1500. Yes. Okay, let me start this again. So I go begin 1100. And you can see right now that it's 1100, right? And if I go here, it's still 1500 because it's happening in the other connection. Okay? I'm going to start this command. Notice it's running, but not completing. The moment I commit, so picture this. Actually, you know what? It's not going to get picked up by the camera, but come with me. Okay? This is okay. You're going to step on the hall for a second. Come with me. I'm going to explain what's happened. Okay? Okay, inside. Okay, we're both coming in. Okay, I'm gonna start on transaction. I'm sitting here, and you can't come in. I'm not letting you in. Okay, I'm gonna step in. So I'm the last person to come in, right? No, right after me. Who's the last person? That's what just happened. He's the 1500. So once I commit it, actually in this case, while we were standing there, it timed out. So now, in theory, I wonder if this one timed out too. I bet you if I commit this and I do the update now, it's still 1500 because the whole thing just timed out. But that's what's happening. So that's the danger with the transactions is if there's multiple transactions touching the same thing at the same time, it's in a queue, one after another. Now, we could do this whole thing again with me blocking you there, but she could come in through that door because she's using a different record. So she can do her thing. But because we're touching the same one. So in that case, we are using last in, first out. LIFO, first in, first out. It's not LIFO. Well, LIFO is used in certain kind of warehousing, but yeah, it's first in, first out like milk. You finish the first carton of milk, and you start the second carton of milk, and it happens that the two cartons of milk are occupying the same space in the fridge. Okay, so this is the demo. Believe it or not, I just showed you how to do the entire lab. 11. If you follow it and you pay attention, lab 11 will take you like 10 minutes to do. And you're not even going to give me the commands. It's literally saying how many rows, how many rows, how many rows now, how many rows now when you do these commands. It's a really quick lab. Okay, you know what? I'm going to start on the content I was supposed to do this week. So we get a little more caught up. Okay, let's go open. No, this. Okay, my computer is having an unhappy day. Okay, let's go here instead. And we go here. Slides, week 12. It should be an axis. It's, hang on. April 21st at 3. I was doing this prep for you guys. Okay, so I'm going to start talking about store procedures and functions. Because technically we got 2 hours for the lecture, and I think I can actually get us caught up to where we need to be by 8 o'clock. Which means next week is the review, and the week after I can just give you guys a day off. Which we can all appreciate. Okay, so from the beginning. Okay, so this is the other big set of slides. There's the second half, a couple of big slides, like for example, transactions had a lot of slides, but some of it was just like a diagram, right? This one's a little more beefy. Okay, so we're gonna talk about store procedures and MySQL functions and the difference between functions and store procedures. Now, all modern database servers allow you to program stuff into the database. I don't mean SQL commands. Those are known as, the word's escaping me. There's an actual word for the commands that happen immediately. Even transactions technically happen immediately. Store procedures, on the other hand, is commands you can store in the server and run later. That's the next set of slides. But they're related. Um, for example, you guys learned how to write functions in Python, right? Picture this as functions you wrote that you can call at any time for code reuse. So a store procedure contains a sequence of SQL commands stored in the database catalog so that it can be invoked later by a program. They're precompiled, which means they're fast. When you create the store procedure, the SQL interpreter figures out how to run it and stores the compiled version. A bit like, I'm guessing I've asked this before, but I'm pretty sure you guys haven't learned about compiled Python programs. You guys have just been doing run the Python program and stuff happens. But you can actually store the bytecode that's generated when you run the Python program. So later on, it doesn't need to interpret it again. It just runs the compiled version. Java's like that too. Um, it operates like a script. Starts at the top, ends at the bottom. They don't return a value. So store procedures just do something. It returns a success or failure, but it doesn't return a value per se. There's ways to make it do that, but it doesn't return a value. You can include select, insert, update, delete, basically anything that's standard DML you can use. It has input and output parameters. This is where I'm talking about how you can get things out of the store procedure, but it doesn't return. You know how you do a function and it returns something at the end? That's not how store procedures work. Store procedures have parameters coming in, and you can actually modify the value of the parameter, and that is actually reflected outside the store procedure. So it's like object-oriented programming where you have properties for a class, and inside of a method or a function, you can modify the property of the class. It's the same idea. Geez, I'm glad I kept going. Otherwise, we've already been left. We would have left by now. Okay. What was that? I'll explain a bit for what you can use it for. Um, it can call functions. It supports transactions inside itself. You cannot use it as part of a join clause because it's self-contained. So there's an example of the syntax, but we're going to go through an example here instead. So we have a table called employee. We have 5 rows. We got 3 departments. Okay. Thus, you can see these slides were created at the command line. So suppose we want to keep track of the total salaries of employees working for each department. So we're going to create a new table called department salaries. So department 1, 2, and 3, total salary in each. Cool beans. But now it's 0. So now we're going to create a procedure to keep these up to date. All right. So here's one of the weird things with MySQL when you create store procedures and functions, stuff like that. You're used to the command delimiter being a semicolon, right? Select star from table, semicolon, update table, semicolon. The problem is that if you have multiple steps in your store procedure, they all have semicolons. The second MySQL sees semicolon, it thinks it's done doing things, right? So what you do is you tell it, hey, ignore semicolons. We're changing your delimiter, your command delimiter, to something else. And you can make it pretty much anything you want, as long as it's kind of unique. So in this case, we're going to change it to double slash. So if you went delimiter double slash, you then would go select star from users, double slash instead of semicolon, and it would recognize that as the end of the command. Something you can't do in Java and JavaScript. And that's a double slash now instead of a semicolon. Yeah. Okay, so I'm going to actually zoom in on this a little bit so you can see it better. I'd rather just, oh, no, that's not what I wanted. This. There we go. Can I get it? No. There we go. Close enough. It's a good thing it's a really low resolution projector. In other classrooms with the high res projectors, like this text is like that big. Okay. Change the delimiter to double slash. Create procedure, update salary in parameter, and it's an integer. So this is saying this is a parameter being passed in. It's going to be called param1, and it's an integer. Pretty much looks like a function declaration that you've seen in Python. Well, not quite, actually in JavaScript, more than Python. Begin. It's not a begin transaction. This is a code begin, like a block. Update department salary, set the total salary to, there's the subquery. To wherever the department number is, parameter 1, where, parameter 1, and so this would just grab a subtotal of the salaries for that department and update the appropriate row in department salaries. And notice there's our semicolon here, there's a semicolon there. But the problem is that if we didn't do the change of the delimiter, this would end it and you'd get an error because it would never reach the end block. So then it reaches the double slashes and suddenly this whole thing is treated as a single command. It'll give you an error because you're chaining commands that you're not supposed to. So for example, if you want to try what he would do, just type in select star from customers, enter, select star from departments, semicolon. You'll get an error because it's trying to run two commands instead of, it's trying to run two commands as one of two separate commands, which is why we have to do the stupid double slash. And then we change the delimiter back so that in the future we can keep using SQL the way we're used to. We only change the delimiter when we're creating or changing procedures. So then in theory, we could go call update salary 1. Notice it's not a select statement, it's call. Procedures are called. They're not part of a select statement, which is why you can't use them in a join because they're called. So 1, 2, 3. Cool beans, we just updated all three departments. There's limitations. So you asked me what are procedures good for? They're good for maintenance jobs. Nightly cleanup. You could use it to truncate tables, to update static views or materialized views, do maintenance, maybe run some analytics, stuff like that. It's things you need to do regularly that are multiple steps and that you could just do a call on instead of having to run a big long script because you've stored it in the database. So nobody needs to worry about it because it's stored with the database. It's covered by the backups. Well, somebody had to write them. Somebody has to write them. Once they're written, everybody can use them. Once they're in the database, it's not your procedure. Everybody can use it if they have enough permissions. But somebody has to create the procedures. Okay. I don't know why there's a green block there. Every year I keep meaning to fix that slide. 1, 2, 3, that's the final result of our procedure. Now, there's a command called show procedure status that shows you the procedures, some of the details about it. So if you create a procedure, you don't remember what you called it, you can go show procedure status, and then you can go find your missing procedures. Okay. If you want to drop a procedure, it's literally drop procedure, whatever it's called, that goes away. Standard DDL. Create, drop. There's no alter. You create and you drop. Okay. So you can declare variables in a stored procedure, just like you can in JavaScript or Python. There's flow control statements, if then else, while and repeat. Basically, it's a do loop. It also has cursors. That's what we're going to talk about next. Cursors are cool. And if there's a link to the, actually, mysqltutorial.org, not the MySQL documentation, mysqltutorial.org has amazing tutorials on this stuff. It goes through in super detail. I've actually simplified these slides because originally these slides even explain to you what a variable was, but by level 2, you guys should know what a variable is. So I got rid of some of these. It actually explained to you, it actually had 3 slides explaining what a loop was. By now, you guys should know what a loop is. If you don't, you've got bigger problems than understanding database. Okay. This one resets our table. The first procedure updates one row at a time, assuming that you always know the departments. That means you have to run the command 3 times for 3 departments, 4 times for 4 departments. It's kind of gross. So we reset everything to 0. Okay, here's a much more complicated, but this one shows everything. All right, so we changed our delimiter this time. We changed to double dollar sign just to show you that it doesn't have to be double slash. It can be as long as it's anything that's unique, that's not a command or a special character. Drop procedure because we want to get rid of it because we're creating it again. Create procedures. Notice there's no parameter now. The original one had a parameter. This one does not. Begin because the code begins here. All right, so here's one of the things about store procedures. You have to declare the variables at the start of the procedure. Have you ever heard of a language called Pascal? Pascal is like that. You have to declare the variables at the top. And it's kind of funny because MySQL is more forgiving. Oracle and Postgres actually has a dedicated section for variable declaration. Much more strict, but you declare them at the beginning. So we're going to declare 2 variables and 2 objects. First variable, done, it's an integer, defaults to 0. Current department number is an integer. So we create 2 variables to hold stuff. Okay, so we're declaring a cursor. So a cursor is a query contained inside of the store procedure that you can operate on. So we're going to declare a cursor for a query called select dnumber from department sal. So this is the SQL statement we want to run. And the cursor is called department dnum cursor. So essentially what this is it's a pointer to the query. The query hasn't run yet, but it's a spot in memory saying this is the command we're going to run attached to this. It's a variable. It's a special kind of variable. It's an object instead of a standard variable. Actually, technically it's a resource, but essentially what's happening is it goes, hey, we're going to declare a cursor here. So it takes a memory address that's identified by the name. And it goes, in this memory address, we're going to run this query, and this is a door into the database. We're opening the window. Then we declare, this is where MySQL is really dumb. Every other database server I've ever worked with, you don't have to do this particularly stupid thing. Okay, declare continue handler for not found. Set done equal to 1. So if a record is not found, it sets the done variable to 1. Because it defaults to 0, because 0 means it's not done, 1 means it's done. So we actually have to have an error handler. It's called a continue handler. It means that, hey, something went wrong, keep going if it's a record not found. So it's as if you have a try-catch. Did you guys learn about try-catch? Try-catch fail? Okay. So picture this being a try-catch. And the catch is, if catch is record not found, you're going to do this and keep going instead of a fail. All right. We open the cursor. At this point, we ran the command, select dnumber from department sal. We initialize the command. We're going to repeat. That's a version of the while loop. Repeat until done. Okay, remember done up here set to 0? So this is going to keep doing this repeat until done is not 0, because then done becomes 1, because 1 is true. 0 is false, because MySQL doesn't have real Booleans. Okay, so what we're going to do is we're going to go fetch dnum cursor into current dnum. So remember we declared current dnum up here. So what it does, it goes, let's fetch the first row of data. The first column is dnumber, because that's what so we're going to take row 1, take the first column, put it in this variable. So we're assigning a variable from retrieving the first row of data in 1 step. In languages like PHP and Python, it's actually a couple of steps to do this. It's actually one of the really efficient, why this is so efficient. There's less code to do the same job. Then we update the department salary just like we did before. And then it loops. Department 2, loops, department 3, loops. It tries to do the fetch. It goes, record not found. Set done to 1. It goes done's equal to 1. It ends the repeat. Closes the cursor because you should always close your cursors. It ends and the job is done. So instead of having a person have to run the command 3 times, we run it once and it loops through all the departments, updating the matching records. And there's the original one. We call it after it's done. It's the exact same thing as if we'd done it manually, one by one. It looks like a lot, but once you start reading through it, it's really no harder than anything else you guys have done in any of your other classes. It's just the language is different. It's kind of like basic, like not basic as in simple, the language basic. It looks like basic. It reads like basic. The if then else statements are the same. Okay, so we're going to write a procedure to give a raise to everybody. Okay, this looks familiar, right? There's our done. There's our cursor. There's our continue. You'll notice we declared an employee ID and a salary. But we'll notice the cursor has 2 columns, ID and salary. Okay. Earlier we only had the 1. Now we have 2. This is what this is showing is what's different. We open the record. We start the repeat until done and repeat. Okay, so this is identical to what you just did. However, fetch the employee record, so fetch the first row into EID and salary. Because we're pulling back 2 columns, we got to populate 2 columns. It may or may not give you an error, and it's positional. So for example, if I were to fetch employee record into salary, comma EID, the employee ID would actually go into the salary, and the salary would go into the EID because it's positional based on, like, the order here has to be the same order as it is there. That's actually one of the pitfalls people trip on. And then we do the update, give everybody a raise. What do you mean the orders? Yeah, you'll have a logic error. Unless, for example, one could be an integer and a varchar, and then you try to put an integer into the varchar or a varchar into an integer, then you'll get an error because the data types don't match. In this case, they're both integers. It would just happen. Then you have a logic bug, not an error. And then it's just a typical update statement and then repeat until done. And then we give everybody a raise, 10% raise, and everybody gets a raise. Yay. You know. Okay. So those are stored procedures. You use them to maintain stuff. Functions. There's not a lot of slides on functions because it uses the exact same language. MySQL has a bunch of functions built in. Upper, lower, min, max, those are all functions. But sometimes you need to have your own function. For whatever reason you want to have your own function, you can create your own function. The difference between functions and stored procedures are functions are compiled at runtime. So every time you call it, it compiles the function. So there's a bit of an overhead as opposed to the procedure, which is precompiled and stored in a precompiled format. Functions must have a return type and can only ever return one value, just like JavaScript, just like Python. Only has select statement. It has input parameters, but no output parameters. It can't be used with transactions. Can't call a store procedure. But it can be used in a join clause. So it's just brutal. So let me just go to an actual function here. Delimiter, but this time we're changing it to a pipe. Just so we can show you that we can do whatever we want. Create function, give raise. Old value double, amount double, and apparently I'm missing my parenthesis at the end, it got cut off. It returns a double because we're returning a double. It's deterministic. Now there's more information about that on another slide, but I'll discuss it right now. Deterministic means if the parameters passed into the function are the same repeatedly, it will always return the same value. So for example, 2 plus 2 is always 4. Right? I hope so. I mean, I've seen the whole, 1 plus 1 is equal to 3 math. Technically, there's a formula to make it do that. It's really dumb, but it's just to show that math is whatever you want it to be. But 2 plus 2 is always 4. That's deterministic, right? On the other hand, I could go 2 times number of student in the room. Depending what week it is, today it would be 10. Last week it would have been 4. That's non-deterministic because we don't know if the value will change. So what happens? The deterministic is like what's called an optimizer. So this morning, somebody ran give raise, fed in 10,000 with 0.1. 3 o'clock this afternoon, that 10,000 and 0.1 will give you the same number. The database server won't even run the function. It goes, I've seen this before. I know what 2 plus 2 is. I don't need to think about it anymore. It's 4. Right? You don't have to think about it because we already know the answer because we've done it once. So then we begin just like the stored procedure. We declare a new variable just like the stored procedure. We set the new value equal to the old value. We return the new value and the procedure ends. And we reset our delimiter. So the big difference between the stored procedure and not is the parameters are all in parameters. You can't even change what kind of parameters they are. You have to tell it if it's deterministic or non-deterministic, and it has to return a value. Just like the deterministic's the only real difference compared to JavaScript or Python. In actual fact, I know with Java and PHP, we can create deterministic functions. You can actually declare a function being deterministic, and it remembers what that function did next time it's called. But JavaScript doesn't have deterministic, and honestly, I'm saying Python doesn't have it. I don't know Python well enough to speak on that. It's got a lot of stuff, and if it didn't, it probably does now. Okay, so here's a slide about deterministic. I just finished explaining it. So if we go select name, salary, give raise, salary, comma 0.1, it gives us the results. So essentially it's running the function on the results of that query, and it's going to show you what the new salary would be. It doesn't change it, it just shows you what it would be. Okay, so functions versus stored procedures. Functions are compiled at runtime. They can only support select statements. They can only ever return one value. Can only handle inbound parameters. It acts like a method. So if you're talking about object-oriented programming, it's like a method on a class. It can be used in join clauses, cannot be used within transactions. And when I say that, it means you can use it in a transaction, but the transaction cannot exist inside the function. The function itself can be used in a transaction, but you cannot use for transactions. But you cannot call the transaction within a function. Okay? Stored procedures are pre-compiled. They support all DML. They cannot return a value, but can output multiple values with the in-out parameters instead. It operates like a script, top to bottom. It cannot be used in a join clause because you call it, you don't select it. And it can have transactions inside of it. Okay. Usually we want to use stored procedures whenever possible because they're more flexible. They also run faster because they're pre-compiled. However, if it's a simple task or it's a weird little job that you need to do part of a select statement, then you create a function for it. Stored procedures are just more performant. Then it lets you do more things, like you can have a transaction inside of it. So example, remember our banking example? We could create a procedure to transfer money. Then we can just call it instead of doing add 50, blah, blah, blah. We could actually go transfer 50 from account A to account B, give the parameters, amount, source, destination account, and then it can have the begin and do all the math itself, but you only have to worry about one command instead of 4 or 5. That's kind of stuff. And that way, the other advantage is once it's written, it's in the database and you never need to worry about the programmers messing it up because it's the database that does it, not the programmer. As the guy who's done databases and programming, I never trusted the programmer. Never trusted myself. Okay. No, the programmers don't have a choice but trust the database. It is what it is. Okay, this one's a lot shorter. It's only 13 slides. And after this, we are technically right where we would have been today 45 minutes ago. It's a lot of information, but it's recorded. You can watch it at your leisure. And even if I wasn't trying to do all in one day, I'd still be moving at this pace. I'm not rushing any more than I would have normally. Okay, triggers, which she brought up. Okay, triggers are cool. Triggers are event-driven actions. When I was going through college, a brand new language had just appeared on the scene. Everybody was amazed by what this language could do. I'm going to age myself so bad. Visual Basic had just been created, and guarantee that probably half the people in this room have never heard of Visual Basic. So Visual Basic was really cool because it was the first time a programmer could design the interface by drag and drop. You could put buttons, fix your form. What was even smarter about it is you could tie events. Visual Basic was an event-driven language where form load, something happens. Button press, something happens. Just like in JavaScript where you on focus, blur, click, double click, right click, changed. Those are all events. Database servers have those too. And there are all database servers support the standard 6 moments. Some have more than MySQL. MySQL has the standard 6 and that's it. But for a lot of people, that's enough. So essentially, we have 2 timings and 3 events, which gives us 6 moments. Before or after, insert, update, and delete. Depending on the database server, the trigger may or may not be part of the transaction. MySQL is a little sketch with the whole trigger and a transaction thing. Other database servers like Postgres and Oracle are much more strict. Okay, so insert, update, or delete. So those are the event that fire the triggers. So essentially, you can tie programmatic code to an insert statement. So every time somebody does an insert, it'll run the programmatic code for. They're not the one writing the insert statement. The database server says, I'm getting an insert statement on this table. I've got code I need to do right now. Everybody's going to wait till I'm done. So as soon as these commands are executed, the listener ensures the trigger is run. So the 6 moments / events before insert. So before the data is inserted into the table, you can write code that modifies what's being inserted. Like for example, adding timestamps, logging, that kind of thing. After insert, after the insert's completed and committed to the table, we can fire a trigger after the fact. Maybe we want to use that for audit logging. Like this seated, let's put a record somewhere else to say, John Doe inserted this row today. Before update, after update, same idea. Before the update, after the update, before delete, or after the data has been deleted. So you have 3 DML commands, and you have before and after each of those. You can choose to program code. If these events don't occur, the trigger does not fire. So for example, you have a delete trigger and you do an insert. There's no insert trigger, so the insert just happens. It only fires the trigger when the event fires off. But you have to be careful because there's certain commands that people will use that don't realize that it's actually doing other commands in the background. For example, the replace command, there's a replace command, and there's a load data command, which lets you load data from a file off the disk. It actually does insert statements. So it'll fire off the insert triggers. You just have to be aware of, some of these things. Okay, so the trigger flow has available data also. So there's specific series of events that happen. There's going to be a chart. Well, you saw the chart already, right? But when the trigger fires off, there's 2 extra data structures. Imagine it loads a record in memory for you to examine. So You have new and old. New is the stuff you're pushing into the database. So it's an insert or an update. When you do an insert and update, you're pushing new values into the database. That's what goes into new. So for example, we're inserting a new email address. So on a table called users, you could go new dot email address, and that would actually let you access, see what's being put in. Old, it's what was there before. So new is valid for insert and update because insert and update adds something to the database or pushes data to the database. Old is valid for update and delete. Insert doesn't have old because you're adding something brand new. There's nothing there. Old was what was there before. And I have an example. I'm pretty sure it's in the slides, but I'll have an example for you guys about how this new and old thing exists. So when you run a trigger, an update trigger, you have two data structures that come into it, new and old. New has the new value pushing in, old is what was there before. So you can say if new email address is equal to old email address, do nothing, or if equal to old email address, maybe you want to log the old email address just to keep track of the audit. Okay, so this is a chart and it's kind of small. Actually, you guys are lucky. Usually it looks even smaller because of the projector's resolutions. Okay, so this is simplified, but this is essentially what happens. The SQL interpreter receives a command. Is it a manipulation command? Is it insert, update, or delete? No, it just executes the query, returns the results because whatever. However, yes, it's an insert command. Is it a valid command? That's the next thing it does. Is it going to run? Yes. If not, it raises an error. Is there a before trigger? Yes or no? If there's no before trigger, it executes the command. If there is one, it executes the before trigger. Did that succeed? Yes. It goes to execute. No. It bombs out. Did it succeed? Did the insert complete? Yes. Goes that way. No. Gives you an error. Is there an after trigger? It executes the after trigger. Did it succeed? Yes. It outputs the results, returns the results to the client. So every time you do an insert and an update, it basically goes through these steps. There's a lot more to it than that, but this is basically what it's doing on the inside. This is, remember I was talking earlier that some database servers and triggers are not function or not transaction safe. MySQL is not transaction safe. So command comes in. It's an insert statement. The before trigger fires off. It's successful. It executes the command. So it did it. Let's say it updated the record to have a timestamp, right? So we don't let the programmer set the timestamp. Let the database manage the timestamp. So it updates the new data with the last modified date. It executes. It does the insert. So it actually writes it to the database. It succeeded. The after trigger fires off, but it fails. Normally in a transaction, if it fails, the whole thing gets done. However, in MySQL, if this fails, it'll tell you something went wrong, but this still happened and it's permanent. So you could get an error coming back saying, hey, this insert failed. The insert actually succeeded. The trigger failed. That's why it's important to write your triggers really well, because you can get false positives like that. Postgres, the whole thing is treated as a single transaction. So before and after triggers are part of the transaction, not. So in Postgres, for example, the insert succeeds, the after trigger fails, the whole thing rolls back. That's, Oracle's like that too. Like, it's just better that way. So advantages of triggers. It can be used to catch errors. So you could have a before insert that's a bit of validation, and you could have it return a false and actually raise a failure. Provides additional methods to schedule tasks. Maybe I've done this. So I had this one system where I needed to update certain tables every day, but the problem is that the whole system ran on a distributed environment, load balanced. So I didn't want all the nodes to fire off this command. I wanted that command to run once first in the morning. So I tied a trigger that was on the user login log, because when somebody logged in, it would log their IP address and went on the insert, and it only said, "Have I done one of these today?" If it had not, it would actually do all the updates on all the tables, and then the rest of the day would ignore it. People complain about, why does it take so long when I'm the first one logging in the morning? Yeah, it's just doing a bit of maintenance. Just don't worry about it. Um, you can keep track of records for tables for auditing. So accounting systems, every single time you change a record, it puts an entry somewhere else so that if it needs to be audited, who made that change? You can use triggers to do the auditing, so it's not the application. Um, you can do data integrity checks. Now, triggers are really cool, but they have some disadvantages. It adds, it requires additional resources because you're running code. It means that the whole thing's going to be a little slower because it's got to run code, do the insert, update, delete, maybe run some more code. So it'll add, a couple of thousandths of a second, or yeah, thousandths of a second. But eventually those will add up. Um, they're invoked from actions on the client side, and they might not have everything you need to know from the server. So, because the client does something, so you hit save on your form on your web page, and it goes an insert. The server runs a trigger. The client doesn't know there's a trigger running. So suddenly the client might suddenly be out of sync with the server because the trigger said no. So you have to be really careful when you write your applications if you're using triggers to make sure you actually double check that things actually did what they're supposed to do. Okay, this slide only applies to MySQL and MariaDB. Triggers cannot execute the following statements: show, load, table, back, flush, and return. They can't be used in transactions. Why? I just explained why. Um, they also cannot call a stored procedure or function. So you can use functions in it, but they can't call the function as itself. So you can't call a stored procedure from inside a trigger because it's not good. All right, so syntax time. Here's an example right here. Then it shows everything you need to know. And the language, very similar to what you've been seeing. Check their delimiter. Create trigger. Product serial number log. After update. On products for each row. Okay, so the trigger is called product serial number log. After update. So after the record has been committed to the database, this trigger needs to fire. It's going to be for products. So every time the products table receives an update, that's when it's going to fire. So this is what it's called. Okay, this is what it's called. This is when it happens. This is the object it's listening on. For each row, triggers have two modes: global, per row. So let's just say we're doing an update products, set serial number equal to null, where product ID is less than 100. So in theory, there could be 100 rows. For each row means it'll fire this trigger for each row being modified. So it'll fire this trigger 100 times. That's the overhead I was talking about, right? If you're doing 1,000 rows, it'll do it 1,000 times. 1,000,000 rows, 1,000,000 times. You can also emit for each row, and that would happen. It would fire it once for the entire command, regardless of how many rows are affected. You can do auditing records with that, for example. So you can choose the granularity of how much it runs. Begin, and here's our end, because always close your begin and end, right? If old serial number is not equal to new serial number, then we want to log the change. But if the serial number didn't change, we don't want to log the change because this is only to log serial number changes. And this trigger has a story behind it. I wrote a trigger that's almost identical to this at my old private sector job. And I'll tell you guys why in a minute. It's a good story. It's a story that involved my company banning the Netherlands in its entirety. Okay, so fairly easy to read. This is the first time you guys see an if statement, but that's what I'm saying. It looks basic because if, then, end if, because that's how you write loops and, if statements in BASIC. So old serial number not equal to new serial number, then we do the insert. If they didn't change, cool beans, we don't need to do the insert because we don't want to log stuff we don't need to log. We can also raise an error in the trigger. So let's say we want something to fail. Create trigger, product log before delete on the product log. So we're going to try to delete. So see in this trigger, we're adding stuff into products log. It's an auditing record. We want to make sure people don't delete anything out of there. So before delete on that table for each row, so for each one we're trying to do, we're going to go signal. It's raising errors in MySQL is so weird. Everything else is like raise error. These guys, it's signal. So you're going to send a signal to the client, take 40,000. That means you find error. Set the message equal to no deleting the data. Okay. End. So what that would happen is if I tried to delete one row, all the rows, before the delete fires off, it'll go, no, you're not allowed to do this. And it just kills the command. And if it's in a transaction, it'll actually fail the transaction. Like it's a hard fail. Okay, so here's the story on this trigger. This would have been circa 2006, so just a few years ago. Most of you were probably somewhere there. I had left my job, but I was still on contract. I'd left my job to go work somewhere else, but I was still on contract with the original company because they didn't have someone to take over my job. So they said, we just want, until we get things stable, we're just on a contract, right? So I'm sitting at my job, and suddenly I get an email from my old job saying, hey, Dan, serial numbers are changing in the database, and we don't know why. I'm like, what do you mean? They're changing, and they're random. They don't look like real serial numbers. Somebody's messing with the database. I'm like, okay. So I walk out of my office, walk into my boss's office, said, can I take like an hour of my own time? I'll make it up later. Old job's calling, and it's urgent. He goes, whatever. Go back to my office. And I'm like, holy crap, it really is changing. So then I created a table to keep track of the old serial numbers as they're changing, because database servers don't have undo, right? So when that serial number is changed, it's permanent. And we lost serial numbers because somebody was going into the system and modifying serial numbers somehow. So I wrote this exact trigger. The only difference is see this log type at the end and this entry updated? We were using a Postgres, not MySQL. Postgres has a special function that says, hey, what's command that triggered this trigger? So I was logging the command that modified the serial number. And I let that run for a little bit because the serial numbers are still changing when I'm doing this. And then I found the SQL statement, and then I searched through the code base, figure out where's this command coming from. It was coming from our product registration system. Somebody had figured out a way to write a bot to hit the API endpoint, because the way that worked is person would register, it would update their serial number in the database, generate an encrypted license file, and return the license file. When you are trying to decrypt anything, the way you do it is you identify a known value, and then you can start figuring out the encryption from the known value. So he was inserting known values into the database, and he was getting license files, and he was trying to figure out. But the problem is that instead of just keep changing the same record over, he was going like, he was literally walking ID1, ID2, ID3, ID4, because I'll be honest, that registration system was really pretty simple and really not safe once we realized what's happening. So in the end, I identified, because I was also logging the IP address, because I had other logs elsewhere that showed the IP address of the people doing stuff. Then I was able to match it up at, oh, this entry happened at this time, and this guy came from the Netherlands. Looked it up, it was coming from an ISP called Ziggo. Here's a fun fact you might not know. In the Netherlands, it's your constitutional right, that's probably a different phrase, but it's your constitutional right to be anonymous on the internet. So they have what they call an anonymous proxy. The thing is anybody in the world can use their anonymous proxies to hide themselves. So we had a hacker, who knows where he was, but he was exiting through the Netherlands through Ziggo. Ziggo is the equivalent of Bell or Rogers. They covered like 80% of the internet clients at the time in the Netherlands. So we banned Ziggo, which essentially we banned all of the Netherlands until I could figure out a way to tighten up the registration system. I played cat and mouse with this guy for 2.5 years. Every time I thought I figured out a way to stop him, he'd come in a different way. So this store procedure is still running to this day. I don't work there anymore. I haven't worked there in almost 4 years now. It's still doing stuff to this day. I'm the only one that knows what's in it though. So not very useful to them, but it's there if ever they really need it. Um, Spent years playing cat and mouse, finding ways to tighten up the registration, not allow certain things to go in. Um, hey, you're trying to update this record, but you're actually passing this ID, and this ID doesn't belong to this product that you're trying to register. So, too bad. I was actually returning 500 errors, like actual server crash errors, on purpose. Server didn't crash. I was telling the client, server just, whatever you just did caused the server to just crash. Um, yes, that's the story behind the procedure. This is like 90% the same as the one I wrote. Logic-wise, it's 98% the same. That's why you want triggers, is for events of that nature. Okay, so that got us to the end of the trigger stuff. Like I said, there's not a lot of there's not a lot of slides on the trigger because the language is the same. You just need to know when the stuff happens because the language is the same. So I usually recommend you do actually, did I simplify this? Hang on, I got to check something. This and the red one. I'm trying to remember if I collapsed the last two labs into one. Oh, I did. So there used to be a lab 9 and a lab 10. There's just lab 9 now. Lab 9 is worth a little more than the other labs because it's more involved. So yeah, you guys have there's lab 11 or lab 8, the transaction lab. Like literally, so establish connection to your MySQL server, depending how you want to do it, one command line, one whatever. Essentially, you're going to run command red in one window, command blue in another window. So two connections, and you're just going to record the results of the query. It's literally like, don't make mistakes, it's 10 minutes. There's only so much to demonstrate all the transactions. The lab 9 used to be lab 9 and 10, but now it's lab 9 because I discovered that students would do lab 9 and then wait to do lab 10, and then they had to remember everything. So it's better if you just do lab 9 as one big lab. So you just, because you're learning new code, right? New language. It's better off if you just do it all in one go. That way you can just do it and be done. Okay. Now that we're caught up to where we're supposed to be, between the weather and technical difficulties, next week will be super quick. I'm just going to go over what's over on the exam. And I'm also going to do a demo of the triggers. So if you actually want to see the actual triggers running, I'm actually going to do some and show them to you. It's a pretty interesting set of triggers. And then after that, the week after, I'm actually going to